Good morning to all of you. Today our subject is engineering thermodynamics or thermodynamics, and topic is first law and study for energy equation. Last classes, previous classes, I have already discussed about theory related to this topic. Now I'll do some problems. Also, I have already done some problems, but these are also important problems. Okay, this is question number 49. 49. The question is the work and heat transfer for degree change of temperature are given by d dollar dt is equal to 100 watt second per degree centigrade and dq at dt is equal to 80 joule per degree centigrade. Clear? Determine the change in internal energy of the system when the temperature increases from 50 to 100 degree centigrade. Clear? This is given what done heat transfer for degree change of temperature. We will find out what is change in internal energy. This is first law. What is the first law? Thermodynamics. dq is equal to d double plus du, or q is equal to double plus delta u, or dq at dt is equal to d double dt plus du at dt. Right? Now, first write given data. Given d double dt is equal to 100 watt second per degree centigrade. What is watt second? 100 watt means joule per second into second by centigrade. Second cancel out. This is d double dt is equal to 100 joule per second. What done for degree temperature rise? Degree temperature. Similarly, dq at dt. dq at dt is equal to 80 joule per degree centigrade. And temperature changes from 50 to 100 degree centigrade. T1. T1 is equal to 50 centigrade. T2 is equal to 100 centigrade. Right? Find change in internal energy. Del U. The question is find del U. Right? Now, d double dt is equal to 100 joule per second. What is d double is equal to? 100 dt. Clear? What d double is equal to? Integration of d double. Limit t1 to t2. Integration of 100 dt. Limit t1 to t2. What t1? 50 centigrade. t2 is equal to 100 centigrade. Right? This is equal to double is equal to 100 t2 minus t1. 100 t2 means 100 minus 50. 100 into 50. 5000 joule. What done is equal to? Right? 5000 joule. Now heat transfer. Now, again, dq by dt is equal to 80 joule per second. Clear? Per centigrade, not second. Joule per centigrade. Clear? So what is dq is equal to? The same place. dq is equal to 80 dt. Right? Integrating both sides. Integrating both sides. So integration of dq is equal to integration of 80 dt. Limit t1 to t2. Limit 0 to q. Now, what is q is equal to? The same place. q is equal to 80 t. Limit t1 to t2. 80 into 100 minus 50. What is q is equal to? 8 into 50. 4000 joule. This is q. What is q is equal to? Heat transfer. W watt transfer. Now the question is find the change in internal energy. Now del U. Del U is equal to change in internal energy. Now, according to law of conservation of energy, according to law of conservation of energy, conservation of energy, what is q is equal to? Q is equal to W plus del U. Right? So 4000 is equal to 5000 plus del U. The same place. Del U is equal to 4000 minus 5000. 1000 joule minus 1000 joule. This is negative. What negative sign? Del U is equal to minus 1000 joule. Negative sign. The negative sign means negative sign indicates the change in internal energy. The change in internal energy of the system decreases. Right? This is del U. Next question number 50. This is our question from first law and law of conservation energy. Clear? Next I will do some problems relating to steady flow energy question. Again second question for first law. From first law. This is question number 50. Right? The question is a fluid system undergoes a non-pro frictionless process. Frictionless reversible process. Clear? Process following the pressure volume relationship P is equal to 4.5 by V plus 2 bar. Means this is bar, where P is in bar and V in meter cube. The volume changes from 0.1 to meter cube volume to 0.4 meter cube, and system rejected 40 kilojoule of heat. Right? Determine the change in internal energy and change in enthalpy. Now, first write the given data, then apply steady flow, apply lap conservation of energy. Okay. Now given this is P, given P is equal to 4.5 by V plus 2 bar, where P is in bar and V in meter cube. Right? The volume changes from 0.1 to meter cube to 0.4 meter cube. That is V1 is equal to 0.1 meter cube and V2 is equal to 0.4 meter cube. Clear? The system rejects 40 kilojoule of heat Q. But Q is equal to minus 40 kilojoule. Rejected. So negative Q. Minus 40 kilojoule. Find the change in internal energy and change in enthalpy. Delta U, del H. These two quantities can be find out. First find out what is work done. Clear? Now, work done is equal to intersection of PdV. This is equal to intersection of 4.5 V plus 2 bar. What is bar? 25. Clear? dV. Right? So what done is equal to this. So W is equal to 4.5 ln V plus 2V whole into 25. There. This is Newton per meter square. This is meter cube. Answer is Newton meter. Joule. This is Joule. This answer is Joule. Now the limit is V1 to V2. V1 to V2. So what done is equal to 4.5 ln V2 by V1 plus 2 into V2 and V1 whole into 25 joule. Right? Put the values of V1 V2. So what done is equal to 4.5 ln V2 by V1 0.4 by 0.12 plus 2 into V2 and V1 0.4 minus 0.12. Clear? This is whole into 25 joule. So 25 by 23 kilojoule. Right? This is 25 joule by 23 kilojoule. Right? This is 100. The answer is W is equal to minus 511 kilojoule. Q is equal to minus 40 kilojoule. Q given. Clear? Now change internal energy. Let del U is equal to change in internal energy. According to law of conservation of energy, what Q is equal to W plus del U. Clear? So what is Q? So minus 40 is equal to minus 511 plus del du. So what del u is equal to minus 40 plus 511 174. So del u is equal to 471 kilojoule. This answer for del u. Right? Now change in enthalpy. Number 1. Number 2, change in enthalpy del H. Del H. Now what del H is equal to? H2 minus H1. What is H? Now H is equal to, we know, enthalpy H is equal to U plus EB. Right? What is enthalpy H1 is equal to? H1 is equal to U1 plus Q1 V1. H2 is equal to U2 plus P2 V2. Right? What is P1, what is P2? First find out what is P1, what is P2. Now P is equal to 4.5 V plus 2 into 100 kilopascal. Bar. So bar means this is 10 to 5. Newton per meter square by 10 to 3 clear kilopascal. 2, right? So what is P is equal to 4.5 by V plus 2 kilonewton per meter square. This is value of P. What is P1? At V1, so P1 is equal to 4.5 by V1 plus 2 into 100 kilopascal. This is 4.5 by what is V1? 0.12 plus 2 into 100 kilonewton per meter square. This is P1 is equal to. This is equal to 3950. P1 is equal to 3950 kilonewton per meter square or kilopascal. P1. P2. Clear? 4.5 baby plus 2 into 100 kilopascal. Similarly, P2. But P2 is equal to 4.5 by V2 plus 2 whole into 100 kilopascal. So P2 is equal to 4.5 by V2. What is V2? 0.4 plus 2 into 100 kilopascal. This is P2. So answer in P2 is equal to, so after solving, you will get the answer P2 is equal to 14.50 kilopascal. 144.50 kilopascal. This P2 is equal to 144.14450 kilopascal. Now H2 minus H1. This enthalpy 1, enthalpy 2. So what is change in enthalpy? Change in enthalpy. Change in enthalpy. Del H is equal to H2 minus H1. What is H2? U2 plus P2 V2 minus U1 plus U1 V1. Right? So del H is equal to U2 minus U1 plus P2 V2 minus U1 V1. Clear? So this is del H is equal to del U plus P2 V2 minus U1 V1. Now what is del U? What del U? 471 kilojoule. Del U is equal to, del H is equal to 471. This is kilojoule plus P2 V2. What is P2? 3950. V2, what is V2? 0.4 meter cube minus P1. Not P2, sorry. P2 is equal to 14450 into V2 is equal to 0.4 minus P1 V1. What is P1? P1 is equal to 3950 V1 1.12. Now this is kilojoule. This is kilonewton per meter square into meter cube. This is kilonewton meter, kilojoule, right? This is kilojoule, this is kilojoule. Now this quantity. This is also kilonewton per meter square into meter cube. So cancels as meter square. This is kilonewton meter, kilojoule, right? All three are kilojoule. So for adding or subtracting, the unit must be same. So this is kilojoule, this is kilojoule, this is kilojoule. Now answer is what the answer? The answer is delta H is equal to 425 kilojoule. 425 kilojoule. You make solution clear and using calculator get the answer. 425 kilojoule. This is question number 50. I will do question of 51. Now, this is question number 51. Clear? The question is, during a reversible constant pressure process with P is 1.5 bar, P pressure, constant pressure, the properties of system changes from BS1 specific volume per meter cube per kg, T1 10 degree centigrade, BS1 0.25 meter cube per kg, T1 10 degree centigrade, to BS2 is equal to 0.45 meter cube per kg and T2 is equal to 240 degree centigrade. Clear? Specific volume, temperature, specific volume, temperature. The satiety of fluid is given by Cp is equal to 1.6 plus 80 by T plus 40 kilojoule per kg. Satiety. Find Q, heat transfer, W, work done, del U, change in energy, del H, change in enthalpy. First, find out heat transfer Q. Now, given data, P is equal to 1.5 bar, 150 kilopascal. Clear? P pressure, satiety volume BS1 is equal to 0.25 meter per kg. T1 is equal to 10 degree centigrade. Clear? BS2 0.45 meter per kg, T2 240 degree centigrade. T2. Right? This is Cp. What is Cp? Saturated constant pressure. Cp is equal to 1.6 plus 80 by T plus 40 kilojoule per kg. Right? Find Q, W, del U, del S. This constant pressure process. This process is constant pressure process. Clear? Constant pressure process. Now, for heat transfer. Heat transfer. Q is equal to Cp into dt, or dq is equal to Cp dt. What is Q is equal to? Integration of Cp dt, limit T1 to T2. Integration with respect to dt. So limit T1 to T2. What is Cp? 1.6 plus 80 by T plus 40 into dt, limit T1 to T2. Right? This is Q is equal to 1.6 T plus 80 log T plus 40, limit T1 to T2. What T1 is equal to 10 degree centigrade, T2 is equal to 240 centigrade. Clear? This implies Q is equal to 1.6 into T2 minus T1 plus 80 log T2 plus 40 minus T1 plus 40. Clear? This is Q. So put in the values. So 40 cancels out. Q is equal to 1.6 into T2 minus T1, 240 minus 10 plus 80 log T2 minus T1, 240 minus 10. Clear? Put in the values. This kilojoule. Answer is kilojoule. Solving, will get Q is equal to, the answer Q is equal to 505.5 kilojoule. This is log. Log m minus log T2 plus 40 minus log T1 plus 40. Right? This is answer. Right? So after solving, the answer becomes Q is equal to, what is answer of Q? Q is equal to 505.5 kilojoule per kg. Clear? This answer for Q. Similarly, double work done. U is equal to 505.5 kilojoule. Work done. Work done is equal to P to V2 minus, or work done is equal to D double is equal to P dV, or double is equal to integration of P dV. Clear? V1 to V2. This will P into V, limit V1 to V2. Right? This W is equal to P into V2 minus V1. What is P? 150 kilopascal, kilonewton per meter square, into V2 minus V1, What is B2? BH2. 0.45 minus B1. 0.25 meter to the power kg. This meter square cancels out meter square. Only kilonewton meter means kilojoule per kg. This W is equal to, after solving you will get W is equal to 30 kilojoule per kg. Clear? 30 kilojoule per kg. What done? This is heat transfer. Now change in internal energy. Change in internal energy. Change in internal energy. Del U. Del U. Now, according to law of conservation of energy, what is Q is equal to double plus del U. Right? What is Q? 505.5 is equal to 30 plus double 30 plus del U. This is kilojoule per kg. This is kilojoule per kg. Clear? So del U is equal to 505 minus 30. 505.5 minus 30 kilojoule. Right? So this del U is equal to 475.5 kilojoule per kg. This is del U. Now heat transfer Q. What done W? Change into del U. All are find out. Now we will find change in enthalpy. Right? Change in enthalpy. Del H. What del H is equal to? Del H is equal to Q. For constant pressure process, Q is equal to mCp to 2 Del H is also Cp into T2 So both Q and delta are same. Del H, what is del H is equal to 505.5 kilojoule per kg. Clear? This is our what done? Heat transfer, change in internal energy, change in enthalpy. Clear? Next question I will do 40, 52. Right? These are all important questions for VPUT. So you follow these questions carefully. Also for GATE exam. 52. This is question number 52. The question is the specified constant pressure Cp of 1 kg of gas, mass 1 kg, or fluid means gas, undergoing a non-flow constant pressure process is given by Cp is equal to 2.5 plus 40 by T plus 20 kilojoule per kg degree centigrade. This is Cp, where T is in degree centigrade. The process is maintained at a 2 bar. The pressure is 2 bar and volume changes from 1 meter cube to 1.8 meter cube, B1, B2, and the temperature changes from 50 to 450 degree centigrade, T1, T2. Find Q. What is Q? Heat transfer. W, work done. Del U, change in internal energy. Del H, change in enthalpy. Clear? Now, first write the given data, then make solution. Clear? Now, mass. What is mass? M is equal to 1 kg. 1 kg mass. Cp is equal to 2.5 plus 40 by T plus 20 kilojoule per kg degree centigrade. Cp. Clear? Cp is equal to M, where T is in centigrade. The process is maintained at a pressure of 2 bar. P is equal to 2 bar. The volume changes from 1 meter cube to 1.8 meter cube. B1 is equal to 1 meter cube, B2 is equal to 1.8 meter cube. Clear? The temperature changes from 50 degree centigrade to 450 degree centigrade, T1. What T1 is equal to 50 centigrade, T2 is equal to 450 centigrade. Find Q, W, del U, del S. Right. First, find heat transfer. Now, given data, Cp, heat transfer. Heat transfer or heat supplied. Q is equal to M Cp dt or dq is equal to M Cp dt. What is Q is equal to? Integration of M Cp dt limit T1 to T2. This integration. T1 means 50, T2 means 450. So, Q is equal to M Cp means 2.5 plus 40 by T plus 20 dt. Clear? This is kg, kilojoule per degree centigrade. Limit T1 to T2. This is Q is equal to M into 2.5 T plus 40 ln T plus 20, T1 to T2, right? So this is Q is equal to M, 1 kg, 1 2.5 into T1 is T1, clear? Plus 40 ln T2 minus plus 20 minus ln T1 plus 20. Clear? This answer. So after solving, the answer becomes 1076 kilojoule. After solving, this Q is equal to 1076 kilojoule. Heat transfer. Right? Now what done? What done is equal to integration of PdV. P means 2 bar. V1 to V limit V1 to V2. So P into V V1 to V2. So this what done is equal to P into V2 minus V1. What is P2 bar means 200 kilopascal. Kilopascal, kilonewton per meter square. So this is equal to 200 V2 minus V1. 1.8 minus 1. Answer kilojoule. What done double is equal to? Clear? W is equal to 160 kilojoule. 160 kilojoule. What done? Then heat transfer. What done? Now change in internal energy. Del U is equal to change in internal energy. Del U. Now what is Q is equal to double del U. So 1076 is equal to 160 per del U plus del U. This implies del U is equal to 1076 minus 160. This is kilojoule. This is kilojoule. The answer is also kilojoule. So del U is equal to 61916 kilojoule. Right? This is 916 kilojoule del U. Now change in enthalpy del S. engine enthalpy del S, right? For constant pressure process, for constant pressure process, Q is equal to del S is equal to 1076 kilojoule, right? For constant pressure process, the change in enthalpy is equal to heat transfer. This answer for question 52. Now I will do 53, last question. 53. This is question number 53. The question is, air is compressed from 1 bar 40 degree centigrade to 40 bar 10 bar P1 P2 isothermally in a reversible process, isothermal process. Find the work done, heat transferred, change in internal energy and change in enthalpy. Clear? Now air is compressed from 1 bar. P1 is 1 bar. T is equal to 40 degree centigrade, T1. P2 is equal to 10 bar. Given data. Air. The question is air. For air. This is isothermal process. Isothermal process means what is isothermal process? Constant temperature. Constant temperature. That is T1 is equal to T2 is equal to 40 degree centigrade. This is 40 plus 273. What is this? 3, 1, 3. 313 Kelvin. T1. Here. T1, T1, T2. Now, P1, V1 by T1 is equal to T2, V2 by T2. This is combined gas law. What is this? Combined gas law. So T1, T2 cancels out. What is P1, V1 is equal to? P2, V2. What is P1 by P2 is equal to? V2 by V1. Clear? Now, for isothermal process, what is work done? Work done is equal to P1, V1 log P2, V1. This is formula for isothermal process. But here, V1 not given, V2 not given. So put V2 by V1 is equal to P1 by P2. Clear? Also, what is P1 V1 is equal to? M bar P1. So what is mass? M1 kg per kg. And V2 by V1 is equal to P1 by P2. Clear? Putting all the values in this equation. Now, what is work done is equal to P1 V1 means M bar T1. Since M is 1, take P1 V1 RT1. This is for m kg. This is RT1 for 1 kg. Right? This is RT1 log P1 by P2. What do I work done is equal to? What done? What is R? For A, R is equal to 0.287 kilojoule per kg Kelvin. This is for A. Clear? Put here. So what done is equal to RT1. What is R? 0.287. What is T1? T1 313 log P1 by P2. P1 1 bar. What is P1? 1 bar. P2 10 bar. 1 by 10. This is what done is good. Now the what done is equal to minus 207 kilojoule per kg. What done? Now change in internal energy. Change in internal energy. Del U is equal to M CB T minus T1. Here T1 T2, so del U is equal to 0. Clear? Similarly, heat transfer. Heat transfer. U is equal to double plus del U. So del U 0. So double plus 0 W minus 207 kilojoule per kg. Minus 207 Q. Clear? Change in enthalpy. Change in enthalpy. Del H M Cp 21. This is 0. Right? This is Q, W, del U, del S. Right? This is question number 53. Next class, I will do some examples. Next, I will do second law of thermodynamics. Clear? Thank you. Please make, like, share, subscribe, and watch the video. Thank you.